Okay, so hello guys. So in this video, what I want to do is I want to show you guys how to do linear equations in one variable. So basically in algebra at the very beginning, so of college, at the very beginning of college algebra, you learn like linear equations and how to solve them using different methods. Now, I'm sure we all know like distributive property. If you guys have questions about that, I can post, or actually, I'm gonna post a short in where I explain what distributive property means. Um, but yeah, I'm not really gonna go over that in this video. I am gonna solve equations using distributive property, but I'm not gonna go over so much like what the definition is. Um, but yeah, so um, we're just solving like multi-step linear equations. Okay, so if we look at the first problem here, we have 2x minus 3 equals 1. So basically, we know that, so basically how you do this one is, so the goal is to get x by itself, right? So we have to get x by itself. So let me rewrite the equation. So 2x minus 3 equals 1, right? And the first thing you're going to do is you're going to add 3 on both sides, okay? So you have plus 3 on both sides, and you have 2x, so this cancels out, you get 2x, and then this equals 1 plus 3, so that's 4. And then the last thing that you're going to do is you're going to divide both sides by 2, okay? So you're going to divide by 2 to get x by itself, right? So you get x is equal to 2. Okay, so the idea here is that we have to get x by itself. We have to solve for x, right? So another thing is that you can check your solution for x. So for x equals 2, you can check it. So let's put like check here. So we're gonna do x equals, so let's see here, maybe x equals 2, right? So we have 2x minus 3 equals 1. So when we plug 2 in, we have 2 times 2 minus 3 equals 1. 2 times 2 is 4, and 4 minus 3 is 1. So 1 is equal to 1. So we did it correctly, right? If you're not sure whether or not you did it correctly, you can always check your solution, right? Okay, so here's our next example. So we have x minus 2 equals negative x, right? So we're going to go ahead and, so the idea here again is you want to get x by itself, right? So the best way in which you can do this is, so we know that we have a variable on the left and on the right. We have to get rid of the variable on one side. So we're going to go ahead and let's add x on both sides, okay? So this gives us, so this becomes 0, right? And we have 2x minus 2 is equal to 0, right? So we have 2x minus 2 equals 0, and now we can go ahead and add 2 to both sides. So we get 2x equals 2, and then we go ahead and divide both sides by 2 to get x equals 1. And like I said, you can check your solution. So check x equals 1, right? So we have x minus 2 equals negative x, right? So we have 1 minus 2 equals negative 1. So we get negative 1 is equal to negative 1. So we did it correctly, right? So your answer is x equals negative 1, right? Okay, so now we're going to go a little bit more tougher. So like I said, this is, so this one, you have to use distributive properties. So if you don't know what distributive property is, okay, A times B plus or minus C equals A B plus or minus A C. You just distribute it, okay? So basically here you're going to distribute your negative here, so you have negative x plus 2 equals, or actually, hold on, my bad. And then you're going to say plus, and then you have 3 times x minus 4, which is 3x minus 12, right? You're multiplying it to both things. And then you have 2x, right? Equals 2x. So then you have negative x plus 2 plus 3x minus 12 equals 2x. So here, 3x minus x is 2x, and then 2 minus 12 is negative 10, and this gives you 2x, right? So this is a perfect example of when a linear equation cannot have a real solution. So if we subtract 2 on both sides, or I'm sorry, 2x on both sides, right? We're going to get that negative 10 is equal to 0. Now, this is a false statement, so meaning that the equation has no real solution, okay? So you will encounter, like, when it has no real solutions, how that looks on a graph. I will go over that in another video, but as in terms of equation, like when you get a number that is not equal to another number, that means that it has no real solution. So this is a perfect example of when a linear function has no real solution, right? Okay, so let's look at this one, right? This one looks a little bit harder. So basically what you're going to do is you're going to distribute. So let me rewrite the problem. So 2x minus 5 times x minus 2 equals 3 times x minus 7 plus 2 times x minus 1. Okay. So what you're going to do is, so you have 2x, right? 2x, and then the negative 5, you're going to distribute it. So it'll be minus 5x, and then negative times negative is positive, so plus 10. And then this is equal to, so you have 3 times x minus 7, so 3x minus 21 plus, and then you'll have another distributive property here, 2x minus 2, right? So then it's a matter of combining like terms, right? So you have something like this, right? That gives you negative 3x plus 10 equals, and then you have a 3x here and a 2x over here. So that'll be 5x, and then minus, and then 21, negative 21 minus 2, that's going to be positive, or I'm sorry, negative 23. Yeah, so minus 23, right? So then you have an x on both sides, so you can add 3x on both sides, right? add 3x, and then you have 10 is equal to 8x minus 23, and then add 23 on both sides, and you get that 33 equals 8x, and then finally divide both sides by 8, and you get that x equals 33 over 8. Okay, so this one is a pretty long one. Okay, so you have to be careful with how you distribute and combine like terms, all that stuff. But yeah, that's how you do that one. Okay, so now we go over the last one. This is the last one I'm going to go over in this video. So let me rewrite it. So 2x minus 4 minus x minus 5 equals negative 3 times x minus 2. Okay, so this one, the 2x, you have 2x minus 4 here, okay? And then you're going to distribute this negative right here. So you're going to say minus x plus 5. And then this is equal to negative, so you're going to do negative 3x, right? Negative 3x, and then negative, so negative times negative is positive, so negative 3 times negative 2 is going to be positive 6. So now, again, it's a matter of combining like terms. So this is 2x, you have 2x negative x, and we also have a negative 4 and a 5. So this will be x plus 1 equals negative 3x plus 6. Okay, so now you're going to add 3x on both sides, right? We have 4x plus 1 equals 6, and then subtract 1 on both sides, and then you have 4x equals 5, and then divide both sides by 4, and you get that x equals 5 over 4, okay? There are a few other ways in which you could solve all of these equations. For example, I could have subtracted x here and gotten negative 2 equals negative 2x and still ended up with x equals 1. Over here, I could have, so even if, well, this one had no real solution, so it didn't matter if I, so even if I subtracted 2x, they both are 2x, so either way I would get no real solution. This one, basically, I could have, let's see, I could have subtracted 5x. So if I would have done that, negative 3x plus 10 equals 5x minus 23, I could have subtracted 5x, right, and gotten negative 8x plus 10 equals negative 23, and then subtracted 10, and then you get negative 8x equals negative 33, and then divide both sides by negative 8, and you would have still gotten the same answer, x equals 33 over 8, right? So these are just other ways, right? Same for this one. I could have, subtracted x and done all of this stuff and then still gotten 5 over 4, right? So those are just other ways in which you could have solved these equations. But I really hope that does help, guys. I'm sorry if the video was kind of long. I really wanted to just go over these examples, but if anybody has any questions whatsoever, please let me know, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.